Okay, here's what the stem and leaf plot would look like. The comparative stem and leaf plot, we have the eastern part of the United States here, based off of the data from above. This is the eastern part. And then we're going to compare it with the western part here, based off of this data here. And so this 6 is 16. And this 5 is 25%. That's this 25%, which is right here, 25%. And then we can use this now to compare using socks. So we could say, as far as shape goes, both of the distributions are symmetric, roughly. Western being much more symmetric, actually perfectly symmetric almost, according to this. Both do not have any outliers or unusual numbers. The center for Eastern, we've decided before, was 11%. That was the center. Whereas Western, we got to count 1, 2, 3, 4, 5, 6. There's the sixth value. 1, 2, 3, 4, 5, 6. So this would be the center for the Western. So the center is higher. The typical value for the Western states is a little bit bigger than the typical value of the Eastern states. That'd be something we'd want to say in our analysis. And then the last thing is spread, variability. About the same amount of variability. Again, we're not going to be able to talk too much about variability until we talk about standard deviation. Okay, histograms. It's called a histogram if you're using quantitative. It's called a bar graph if you're using categorical. Okay, remember there are two types of quantitative data. There's discrete and continuous, so we will treat them just a little differently as we work through this. That was the last lesson. Okay, so you can use histograms for larger data sets. Just easier. You don't have to do a bunch of dots and stuff like that. So here's how you would draw it. Here's an example. We have data. The following data are the number of partners for 30 queen bees. So pause the video if you'd like to read through that. But in general, make yourself a horizontal, make yourself a vertical. On the vertical, it doesn't matter if you use the frequency or the relative frequency. Relative frequency was from last lesson. Doesn't matter. They're both identical if you do the same. It just works out that way. So here are two histograms showing the queen bee data set. One uses frequency and one uses relative frequency. What do you notice about the shapes? Write a sentence about the distribution. So if we want to write about the distribution, you got to hit socks again. So we could say that it's, if we were to draw this shape, it'd be like this. So this is still kind of unimodal, even though you could maybe say there's that. If this bar was up here at the same height as this bar, then we could say bimodal. But for the most part, it's unimodal. And I bet if we got more data, it would be better. Fairly symmetric, we would say. The center is about 7. That's your typical value, 7 partners. And there's a little bit more variability. It's more spread out. You've got quite a few things at the tails of the data set, so a little bit more spread out, a little bit more variability. Continuous for data. You're going to use intervals. So like with discrete, it's countable. You have 1 partner, 2 partners, 3 partners, 4 partners. For continuous data, you've got an interval. So here's an example, and it's the same thing. This are the carry-on luggage weight. Now weight can take on any value between 0 pounds to whatever their limit is, 50 pounds. It can be any number, so it's continuous because it can take on any amount of weight between 0 and say 50. And you round it, and then you can take these and you can take them over and plot them on dots there. So you got to be careful because we're going to end up making a bar like here. So if we make this interval right here, we need to include 10 or include 15. One of the ends needs to be included. So we could do like this is the interval that includes 10 but does not include 15. So anything between 10 and 15 including 10. And then this interval will include 15 up to 20. This interval will include 20 up to 25, not equal to 25. And then what you can do is you can just kind of count the number of dots in the interval and just display them like that, and then we turn them into bars. Okay. So go ahead and read through this. You can pause the video, read through it. The middle dot plot shows all the data values in each interval stacked. So in the middle here, this 20 to 25. We're going to include this one, so we count them 1, 2, 3, 4, 5, 6, 7, but we don't include these. So that's why there is 1, 2, 3, 4, 5, 6, 7. You don't want to overlap, but not including 15. You can do comparative histograms, like comparative dot plots. You have to do them separately, just like you do dot plots separately. You have to use 2, and that's because it's better. They might be different sample sizes. Okay, so you might have 100 1-year-olds that you're looking at versus 300 3-year-olds. And by looking at the relative frequency, you're looking at like the proportions. You can compare the proportions like that. So here we have example 8. You can go ahead and read through that. Biggest difference, if we're looking at socks again, the shape. They're both unimodal. And they're both skewed to the right. Outliers, we don't know what an outlier is, but nothing's out of the norm. There's no big gaps there. We'll talk about outliers again in the future. Center, that's probably the biggest difference between these. The center for 1-year-olds is probably greater than 2, whereas the center for 3-year-olds is probably less than 2. You've got the majority of stuff here. And as far as variability, the spread, it's a little bit more spread out for 3-year-olds. You got a little bit of more data here on the tail end, but they're kind of similar as far as variability goes. Next and last thing here is when you use unequal width intervals. So these were equal width intervals, 2 to 6, 6 to 8, 8 to 10, equal width intervals. It's possible that you could use unequal width intervals, and there's a problem that happens when you do that. When you have unequal intervals, you plot density. It's called density, and that's the relative frequency divided by the width of the interval. So here's an example of what can happen with unequal intervals. So pause the video, read through example 9 for a moment, and we're unpaused. So if we were to plot this based off of this interval, so -2 to -0.4, and then we plotted the relative frequency, which was right there. The width was 1.6 units wide, and the relative frequency was about 2%. So this represents about 2%. And over here, this represents about 17%. And which of these is the most represented? 21%. So that's the interval from 0.1 to 0, -0.1 to 0. That's this interval right here. So this is the most represented part of this data at 21%. This is 21%. And this is about 17%. Does that look right? Not really. This looks a lot bigger than this. So to get around that, to fix that, instead of marking the relative frequency on the vertical axis, you mark the density on the vertical axis. And the density is found with using this equation here. Ow. I'm wearing my mask. My mask just snapped on my face. So for density, we would take 0.023 and divide it by 1.6, like that, to get 0.014. Okay, so pause the video and go ahead and do that. Take that and divide it by that for all of these. You end up at okay, so instead of graphing relative frequency and the intervals, we're going to graph the density and the intervals. And now, this thing here, yeah, it does look like 17%. And you can see that this right here is the largest of all of them at 21%. And you can kind of see that. And like in this picture, it's not even close, right? This isn't even the largest in the picture, but it's the largest of the data set. Whereas in this picture, it is the largest in the picture, and it's the largest proportion of the data set. So, moral of the story, when you have unequal intervals, you plot density and the interval width for your bars. And that will make it more visually appropriate. There's one more thing called a cumulative relative frequency plot, and I'm just going to have you read it. It's two pages. Just go in your book and read those about the cumulative relative frequency plot. For your homework tonight, what I'm going to do is oops, I guess I have a typo in there. You have to do 2.25 through 2.30 and 2.36. I'll post that online and make sure that's correct. Okay, so look online. For these 2.25 through 2.30, you need to, I'm not going to make you do the graph because they're very time consuming and your time is important. But it is important to know how to make the plots. So what I'm going to say is you just need to go to the solutions and look at the plots. So in these questions, when it says to make the plot, you can just go and look at the solutions and then answer your questions from there. So you do not need to put the plot on your homework. It's up to you if you want to do that, but it's going to take you a lot of time. Therefore, the questions ask you to plot, you can skip that part and look at the solutions. You do not need to recreate the plot in your homework. you do need to do 2.36 in its entirety. Okay, so there you do have to plot that one just a little bit. You don't have to be too detailed, but so there you have it. That's the lesson. We're laying the foundation. This is chapter 2. Chapter 3, we start computing.